Hello everyone, my name is Nehal Yadav, studying in Sri Venkateswara College of Engineering, Bangalore. My USN is 1VE23ZA033. I am studying in Section DB, Department Basic Science, in course Artificial Intelligence, and my subject code is BMATS201. My subject title is Mathematics 2 for CSE stream. Our today's topic is precision in approximation strategies for estimating roots. So we'll find out how to estimate roots. So what are the different methods we can use for estimating roots, which is a very useful process. So introduction. So understanding roots and their importance in mathematical approximation. So exploring strategies for estimating roots with precision. Key concepts and applications in real world scenarios. Understanding roots. So what do you mean by a root? So defining the concept of roots in mathematics. So exploring the significance of finding accurate roots in various mathematical problems. So examples of real world applications of root testing. So there are where various real world applications in real life where we use to find the root estimation. So we'll find out what are those and what are the uses of those. Importance of approximation. So highlighting the role of approximation in mathematical calculation. So discussing the impact of precision in estimation on the accuracy of results. So real life examples of the consequences of inaccurate approximation. So what is that? So we'll highlight the role of approximation in mathematical calculation. So we'll discuss impact of precision in estimation on the accuracy of results. So which are real life examples of the consequences of inaccurate approximation. So exploring various strategies for estimating roots, including the bisection method, root Newton's method, and secant method, comparing the advantages and limitations of each approach. So there are three different methods to estimate the roots. So there are bisection method, so Newton's method, and secant method. So we'll be comparing the advantages and limitations of each approach. So bisection method. So in-depth explanation of the bisection method for root estimate. So we'll now find out how to do the bisection method. Step-by-step process and mathematical principles involved in using this strategy. So numerical examples to demonstrate its application. So bisection. So bisection is bisecting an angle into two different parts or three different parts which we require. So based on the example or based on the requirements we need. So this is nothing but a bisection method, which is a very useful method. So, so the second one is Newton's method. So what is Newton's method? So Newton's method is a comprehensive overview of Newton's method for root approximation. So there are different Newton's methods. So this is a method for root approximation. So understanding the iterative process. So iterative which means the repeated process and convergence criteria for this approach. So practical examples to illustrate its effectiveness. So Newton's method is nothing but it's understanding the iterative process and convergence criteria for this approach. So practical examples to illustrate its effectiveness. This is nothing but a Newton's method. So which is here you can see the bottle which is iterating or so that we can find the roots until which number of roots we can find. So this is nothing but Newton's method. So two methods which is called bisection method and Newton's method we have seen. So the third method which we will be dealing is about the detailed explanation of the secant method for estimating roots. So comparing the secant method with Newton's method and bisection method. So applications and scenarios where the secant method is advantage. So while comparing Newton's method and secant method. So there are some comparisons and scenarios which will be advantages. So we'll be looking out to that. So precision and convergence. So emphasizing the significance of precision in root approximation. So understanding the convergence criteria and its relationship to accurate estimation. So practical implications of achieving convergence in root estimation. So what we'll be doing is with the emphasizing the significance of precision in root approximation. So understanding convergence criteria, we have done during the secant method and the root approximation method, which is also known as Newton's law method, and its relationship to accurate estimation. The practical implications of achieving convergence in root estimation. So what are the real world applications? So examining real world scenarios where accurate route estimation is crucial. So route estimation is very crucial in different aspects of life, which are we'll be doing. We'll learn with the secant method and the Newton method. And so examples from engineering, finance, and scientific research. So examples are we can find out in engineering, finance, and scientific research. So demonstrating the impact of precision in route approximation on decision-making processes. So these are some route estimation processes which are engineering, finance, and scientific research. So challenges and limitation. So we'll be dealing with identifying the challenges and limitation associated with root estimation, which will be found out with secant method. The Newton law method. The secant method is bisecting method is where with bisecting which will two different parts, and Newton's method will be of iterating the processes into how many roots we require based on the condition and the problem. So what are the challenges and limitations of this method? So identifying the challenges and limitations associated with root estimation. So discussing factors that can affect the precision of approximation method. So strategies for mitigating potential errors in estimation. There will be some errors in the estimation which will be found out in the challenges and limitations. So what are the future developments? So exploring emerging technologies and innovative approaches for enhancing precision in route approximation. So anticipated advancements in computational methods and algorithms. So algorithms and computational methods are also used in advancements. So potential impact on various industries and research fields. So potential impact on various industries and research fields. So these are some developments which can be done for the estimating of approximation routes. So conclusion. So summarizing the key takeaways from the presentation. So reinforcing the importance of precision in route approximation. So encouraging further exploration and application of advanced estimation strategies. We have seen these ones. So let's recall all these ones. So there are three different methods, which is called Newton's method, secant method, and bisection method. So bisection method is nothing but we're bisecting the angle in which in how many quadrants or in how many angles we want, in how many parts we want. So the next is a Newton's method where it's iterative process and convergence criteria for this approach. So the iterative process is nothing but a continuous process of iterating. So the next is a secant method, which is a comparison of both Newton's method and bisection method is called the secant method. And then precision and convergence, emphasizing the significance of precision in route approximation. So understanding convergence criteria and its relationship to accurate estimation. So practical implications of achieving convergence in route estimation. So real world applications which I have seen like they are used in engineering, finance, and scientific research. Challenges and limitations are currently associated with route estimation, discussing factors can affect the precision of approximation methods. So future developments for enhancing precision route approximation. So conclusion will be taking of these and all of the topics we have learned today. So thank you for